Hello. I assume everyone can hear me just fine. Thank you. So, by means of a quick introduction, I'm Viral Shah, and I have my co-author, Dr. Elisabeth Roesch, and we are going to talk about all the fun things that you can do with Julia and biology, and pharmacometrics and various things that we've been up to over the last several years since I last spoke at R in Pharma, I believe, almost 3 years ago. Right. So I am one of the creators of the Julia language, and one of the things that was most exciting about creating Julia for us was that we wanted to have a language that solves the two language problem. And what is the two language problem, you might wonder? So you know all of us as engineers and scientists are used to this idea of working in high level domain specific languages, languages like R or Python, MATLAB, which are easy to work with. They tend to be dynamic, they tend to be interactive, they have plotting, and they make it very easy to prototype algorithms. But then when you need to run these codes at scale, for example, if you need to, run a very large bioinformatics workload, or if you want to, deploy your code to an actual device, you often have to rewrite that code in C. And what we really wanted was something that had the ease of use of R, but the speed of C, and that's what led to the creation of Julia way back in 2009. That's when we started the project at MIT, and we've been here at it for almost 15 years now. This chart actually is showing the two language problem in action here. So on the x-axis you have the compress, the size of the code for a benchmark, and on the y-axis you have the execution time. So you almost want to be sort of at the bottom left corner of this chart, which would suggest that you're able to write compact code and run it as fast as possible. We don't have R on this. This was actually a chart that was put together by someone else in the community. It doesn't have R, but I would expect that R would be similar to some of the other interactive and dynamic languages on this chart. Oops. So the Julia community is growing, and we started out with modest downloads back in 2016. These downloads are in millions, and we're close to 50 million downloads by the end of this year. We have a fantastic YouTube channel that has all the videos from every JuliaCon and many workshop and training videos. If you're new to Julia, I would recommend check out the JuliaCon channel, or rather the Julia language channel on YouTube. We have a very active discussion forum. It's called discourse.julialang.org, and it has almost 15,000 people on it. Julia has been well covered in the news, and there are over 10,000 open source packages in Julia today. Now, people sometimes ask, like, hey, your Julia is a relatively newer language. Python and R go all the way back to the 90s, and so will I have all the packages I need? And I usually say that this is a two-part answer. First of all, Julia does have 10,000 open source packages, but you can also call any R package from Julia. You can call any Python package from Julia. You can call any C or Fortran library from Julia. And so, in some sense, Julia actually has the combination of all the possible package ecosystems that are available out there. It provides all of those at your fingertips. We believe that Julia is the next generation technical computing language because it combines the ease of use and the speed. It was purpose built for technical computing, and it's a vibrant and growing ecosystem. Back in 2022, it was voted on Stack Overflow as the fifth most loved programming language, a little ahead of Python and R, and way ahead of MATLAB. For some of you who are wondering, does anyone really use Julia? So, this tends to be a very personal question. If you know people who use Julia, you think everyone's using Julia. If you don't know a single person using Julia, you think no one's using Julia. And one of the things that happened just in August of this year was that Julia cracked the top 20 in TIOB's popularity index. And by no means am I suggesting that these indexes are a way to measure the true adoption of a language, but I believe that the trends are real, and we started at 47 in 2017, and we made it to top 20 in 2023 today. And this is actually a very hard climb. I mean, the top 20 are, have been there, have been in development for many decades, and we're thrilled to be in that company. And make our goal is to keep making Julia nicer and easier to work with, and our mission is to empower scientists and engineers, and that's why we're here today. There's growing adoption in the pharmaceutical community in Julia. I wanted to bring attention to tidier.jl, which is a package in Julia by Professor Karandeep Singh, who's at University of Michigan. Gave a beautiful talk at JuliaCon on bringing the tidyverse to Julia. If you want to get started, there's a fantastic workshop on using data frames with Julia, also from this year's JuliaCon. Modeling and simulation to guide dosage selection was what Moderna did with Julia, and that's how they describe how Julia played a role in the validation of their vaccines. And we have folks from various companies talking about QSP, which my colleague Elisabeth is going to talk a lot more about. And then there's a tremendous amount of contributions from universities and various groups across the world. So head over to the Julia channel on YouTube and look at some of these talks. We will be uploading these slides, and Elisabeth will be sharing more details about where, so you can actually click through these links. So one of the questions that comes up a lot about Julia, especially in pharmaceuticals, is that hey, what's the story around sustainability of open source? And this was the question we were faced with way back when we started working with our colleagues at Pumas AI. And it was very clear that there is this role for Julia as a language for data science, which is open source, as this fantastic ecosystem around data frames and tools like tidier.jl and plotting and parallel computing and GPUs and machine learning, and all the SciML stuff that Krishna Kakis has built. But at the end of the day, in order to keep this community vibrant and these packages supported, we also partnered with our colleagues at Pumas AI to create the Pumas Enterprise Suite, which takes the power of Julia and really focuses it on building a set of pharmacometric tools. And this suite includes these 4 tools out here. And it's this is a robust platform. It's what we as a company at Julia Hub provide. And I would I just wanted to kind of give a quick glimpse of it, that while we add a lot of GUIs and capabilities to the product, we also focus on actually making these tools easy to use by programmers. So the Pumas modeling language is a model macro in Julia itself, and it's a way that you can just fire up your editor, type out your model, hit execute, and then start interacting with it, and so on and so forth. And this is where I hand over the talk to Elisabeth to actually show off Julia and a few demos.
Hi, thank you very much. I assume you can hear me well?
Yes.
Awesome. Okay, so first things first, as Roesch mentioned, here's a link for you to find all the material we are presenting today. So that brings you to a GitHub repository. So just use this bit.ly link or scan this QR code. I'm going to run you through a few notebooks where I want to show you some fairly simple Julia workflows. But there you also find a big collection of links from what Roesch has just shown you. So when it comes to further resources and where you can start learning Julia, or if you are particularly working currently in R and you're looking to how do I make this transition to Julia as easy as possible, we've collected a number of resources that would be helpful for you to check out. So regarding this figure, Roesch already has mentioned this. I'm stealing this from one of our papers that we published this year in Nature Methods for Julia and biologists. So this is a depiction of the 2-language problem that Roesch was already discussing. So we're really comparing on the day-to-day life side of a biologist or a life scientist in general. How does your workflows, how does your model development, your model simulation compare, whether you are in Julia or somewhere else like in R, Python, and MATLAB. And we have isolated here 3 features that we really try to focus on. So that is speed, metaprogramming, and abstraction. So these are really the core elements where we say this language is really very different to what we see people experiencing in R, Python, or MATLAB. Here I've just linked some more resources that Viral already has mentioned as well. So this is really the more high level real world impact that you see pharmaceutical industries experiencing when they use Julia. So the three that I want to highlight here is a Pfizer study and an AstraZeneca study and a United Therapeutic Studies. United Therapeutic Study. So those really show you more bigger picture, like how it improved their workflow. Whereas now in my talk, I really want to focus more on like get you a sense of what Julia feels like in simple workflows. So the packages in Julia, Viral has already mentioned. So here I'm again stealing a figure from our paper. Here I'm depicting some of the packages that we would consider most relevant for people using Julia in biology, in life science, or in the pharmaceutical sciences. So just I want to highlight a little bit this section because Viral has mentioned this already. So integration of non-Julia code in Julia. If you say somehow in these 10,000 packages, you cannot find the methodology that you want, or you need to exactly reproduce a study that a colleague has done or a benchmark that you want to conduct, these integration packages of non-Julia code is really, really helpful. But then there's much more, of course, like data handling, visualization tools, dimensionality reduction, then more like inferences, optimization. If you work a lot with data, you want to learn from this data, and so on. Here I'm going to show you how I use two packages specifically. This is CSV and data frame. So I want to really put the data in the center of this workflow. I'm looking at two different clinical conditions. So here you can see we are loading into data frame 1 and data frame 2. I call them dfclin con 2. Then here you have dfclin con 1. And what I'm showing here is really just like depicting the data, right? So I say, okay, this CSV file, read it into Julia as a data frame. And then I can see here we have our columns. We've got all our, like the content. You can fold this out even further. So I'm showing this here in the setting of a notebook, but obviously you can access Julia with many, many different ways. This is just really nice for demos like in a conference talk or when you speak to your colleagues and things like that. Here I'm showing one aspect that we also highlight in the figure of the true language problem, which is the speed aspect. So what I'm showing here, I'm just visualizing well, let's start here. Like it's an X and an Y. So I'm plotting here X as just the time from that data frame, and Y I'm plotting as a operation of different columns. So I say, okay, let's take one column, divide it by another column, subtract it from another column, and then do everything to the power of 2. So in some languages, you really have to be careful if you're concatenating those things, or if you're creating these loops where you do element-wise operations, but like repetitively over some linearizable code. In Julia, this is a little bit different. So if you look closely, you can see I'm not just doing divide, and I'm not just doing the subtraction, but I'm using this dot operator prior to the operation you're probably used to. And here we can then fuse together those operations into one single call. And that does result in like us seeing a big speed improvements if we compare to languages such as R, for example. So this is the figure that we use in our paper to demonstrate that. And I'm just going to zoom in a little bit here so you can see this a bit better. I won't go through everything, but we are showing two cases of this speed. This is for linearizable code. This example is for non-linearizable code. So here we can see exactly what we have observed just before. We are comparing Julia and R when it comes to operations on a table. So it's single cell data inference. Like we are trying to infer gene regulatory networks of single cell data, and they have added a study of their comparing their workflows to R. This one is from the area of differential equations. So I will actually show you more about this model in just a second. And here we go more into an intuitive explanation of why we see those speed differences. This one here, we compare, we explain basically what happens here, but we compare to Python instead of R. So, but this is exactly these intermediate allocations and like sequential computation instead of fusing it together with the broadcast operator that I just showed you. So if this is very interesting to you, I would highly encourage you to look at the paper. There we go, obviously, through this in much more detail. Then another aspect I really wanted to mention here is like how you can add interactivity to visualizations, or just what the visualizations feel like. So this is the most simple version of how we add this interactivity. So we're just adding these HTML objects like these sliders, and then I can say, okay, if we assume now my time is measured in days, right? I can just here change the days that I'm picking from my table, and I can visualize different days just as such. There are many other packages that also allow you to integrate these these interactive aspects. This is just really like to give you a sense of like what type of figures you can create. So if I scroll all the way back up, I did hide one something here. So the data that I'm actually looking at for in these data frames is from this modeling toolkit model, and this is the base that we use for things like Puma's QSP, which is one of the packages that we use in the Puma suite. So I just want to show you a little bit about how this would look in a Puma's QSP workflow. So you can see it's exactly the same type of definition. We use modeling toolkit. You end up with an ODE system. You have states that you observe, in this case over time, so your parameters, differential equations. You can easily visualize how they behave over time. And then here we are looking exactly at the same data. We just add a little bit more complexity to the problem. And then what Puma's QSP allows you is that it allows you to very intuitively capture how data and model interact with each other in different clinical conditions. And then it's really all about integrating that into some calibration optimization procedures, so such as virtual population analysis, virtual cohort analysis, or in the direction of global sensitivity analysis. So this is really just a very, very high level perspective over many, many different things. I really want to encourage you to just scan the link and have a browse through. And the GitHub repository, I'm linking all these notebooks. I also give you more resources if there's particular domains you're more interested in. So I want to leave just a little bit for questions. Yeah.
All right, awesome. Great presentation, guys. Nice to see the development of Julia and how it's coming along. It's awesome. Eric, maybe we have time for one or two questions, if you can put. All right, a question from Fernanda. Okay, Julia is good, but where are they teaching how to use this language? So some information on resources for that?
Miral, do you want to go, or should I?
Go for it, Elisabeth.
So I think it depends where you would like to, where you want to start. So this, I would say the first one is this link. Just follow this link that I post here. There's a collection of links where you want to go next. So there is the YouTube channels. There is the Julia Academy. There is there are notebooks domain specifics. There are scripts domain specific that really start teaching you Julia with a framework that you seem to be a methodological framework you're comfortable with. So there are many options. If you prefer reading, there are papers you can read. There are many books about the Julia language. I think the Academy is probably the most interactive, fun way to learn it. And otherwise, I think community is huge in Julia. So join the Slack channels, join the Zulip channels, whatever you like. Find the people that work in similar areas as you do and connect.
All right.
Yeah, I would just say that if you go to julialang.org, there's a just /learning. That's a link that I posted in the comments there. So check that out as well. Or if you would like to work with Julia commercially, reach out to us at juliahub.com, sales@juliahub.com, or me or Elisabeth directly.
Excellent. Awesome. We don't have time for more questions. I encourage everyone to reach out to both you guys directly and get some more questions and get some more information about Julia. It's lovely discussion here.
Paulo, I just wanted to give out a huge thanks to Elisabeth, who's actually presenting from Australia at 4 a.m. So I'm sure your audience will approve that.
Very nice.
Sometimes.
Bravo. Bravo.
No worries.
All right. Thank you. Thank you, guys.